All right, ladies and gentlemen, welcome to another video here. So today I'm going to be going over an SAT question. Uh, Most of these questions I grabbed from several books that I am going to place on the description down below. I also grabbed them from numerous textbooks that have higher order thinking questions that I assume would possibly be in the SATs. They're mainly higher order thinking questions anyways, so I figured I also, well, technically the reason that I make these videos is because I am studying for my Praxis 2 exam, so I gather questions from numerous high school textbooks and SAT textbooks, or well, yeah, I guess you can call it, or workbooks. We should call them workbooks. But they're pretty much from people who have taken the SATs, and obviously the high school textbooks are written by professors at the college level. So, and by the way, those are probably the people who create the questions, anyways, for state exams and or SATs. So, here we have a question that says a circle is inscribed in an equilateral triangle. Basically, what that means is that the circle is inside. So, inscribed basically means it's inside an equilateral triangle. The radius of the circle is 9 inches. What is the perimeter in inches of the triangle? So I'm wondering if I could move this, because I'd love to move this bottom piece that I cannot move, but we can erase that. All right, so anyways, it says that the radius is 9 inches. The first thing I'm going to do is draw a radius from the very bottom to the center, or try at least to put it to the center. That is 9 inches. I'm going to put 9 in, okay, IN for inches. The other piece of information, or the question was, what is the perimeter in inches of the triangle? So I need to figure out a way that I can get the side of a triangle. Well, I can connect one of the vertices to the radius. Okay, one of the vertices of the triangle to the radius. And we know that this is 60 degrees. So we'll point that out there because it's 60 degrees because it's an equilateral triangle. So all of these vertices are 60 degrees. So if I connect this radius, or this point, to a vertice, I split this angle right here. Let me put this green. I split this angle, so it's no longer 60. It is now 30 degrees in the inside. It's 30 degrees here. We also have a 90 degree here, and because this one, this 30 and this 90 add to 120, it means the very last degree here is going to be 60 degrees. So here we have a 30, 60, 90. Now, 30 will be the smallest, and the rule for the 30, 60, 90 is that one side is x, one side is x root 3, and the other side is 2x. So the one that receives the 30, or the one that receives the x is 30 degrees. The one that receives the 60 degrees is the x root 3. And obviously 90 degree being the largest measure in the angle for a 30, 60, 90 will receive the largest measure, 2x. So because 30 receives the x opposite to it, then 9 is equal to x. And this is how we can find the very bottom. 90 degrees is, well, we don't really need to know what this side is. This is 2x, but we don't really need to know what that side is. I want to get this side here at the bottom, because that is going to be the one that is next to the side of a triangle. So we have 9 root 3, because x root 3 is, oh, let me erase that. It doesn't look very good. We have x root 3 at the bottom of the opposite side of 60 degrees. So here's 60 degrees, here's 60 degrees. Opposite to that would mean we get the side that has the x root 3. And we established that x is equal to 9 because 30 degrees, opposite of 30 degrees, is the smallest measure, which is the radius of this circle. So we're not done yet, because that is only half of the base. And to get the other half of the base, well, we just have to add another 9 root 3 or multiply by 2. And that is going to give us 18 root 3. Now, because this is an equilateral triangle, every side is the same. So either you can just add 18 root 3 three times, or you can just multiply by 3 because this is an equilateral triangle. And when you multiply 3 by 18, you're going to get 54 root 3. And that is the perimeter of this triangle.